Hey guys, I wanted to show you a little bit about some of my notes here on titration that I've drawn out. And just to help you understand this, I think between the videos that we can watch and the lab activity things that we can do, the simulated labs, I think we can figure this out pretty well. So I want to show you this thing on titration. And titration is an analytical technique that we use to determine the concentration of an unknown substance. And so that's kind of the definition that we use. So we use this in cases of acid-base titrations, and we can use them in redox titrations. So it's a common technique that we use. And so what we do is we take one substance of an unknown concentration, and then we titrate it with a solution of known concentration, and that's very important. The thing about the unknown solution, though, is that we do know its volume. We can measure that accurately. Now, there are a bunch of different titrations, and today I want to start us out with just strong acid, strong base titrations. I think since we're doing this online, I probably won't get too far into this with different types of titrations, the strong acid, strong base being the simplest. And remember, strong acids and strong bases both dissociate completely, 100%, in aqueous solution. All right, so here's kind of how this looks. If we were to have some strong acid just sitting in maybe a flask over here, and we were to measure its pH using a pH meter, you'd see that the strong acid would have a pH on the pH scale that would be very low, down here approaching 0. Since it's a strong acid, we'd have a lot of extra H plus ions. But if we would start to drip some of this base in there, some sodium hydroxide right into there, we would notice the pH would stay relatively the same for a long time, but then all of a sudden we'd see this big shift in the pH, and it would start to rise. As soon as we got to the point where there were more OH minus ions than there were H plus ions. And so it would rise very rapidly, and then the solution would resemble more of the base than the acid after we'd used up all of those H plus ions and neutralized them. This is called the neutralization reaction, and we're just going to react a strong acid with a strong base and neutralize one with the other. Now, the point where the acid equals the base is called the equivalence point, and there's a little more technical definition here, but think of it as the point here in the middle, and we're going to see that right around a pH of 7 with our strong acid and strong base. Now, when we select an indicator is usually a weak acid or a weak base, and it changes color depending on whether it has a hydrogen ion on it or not. And so one of these weak acids and their salt will work out that way. So all we have to do is pick an indicator so that the equivalence point, that's right here, of the titration is within the transition range of the indicator. So like below this, we might pick one called bromothiamyl blue. Bromothiamyl blue is yellow below a pH of 6. So down here our solution would be yellow. And as we drip base into it, it would turn blue right at this point. And so above 7.6. So as long as our equivalence point is within the transition range, 6.0 to 7.6, then that would be an appropriate indicator for this. Now, over here is the titration setup. We take a burette tube and we take a flask. We put our solution of acid in the flask with a couple of drops of bromothiamyl blue. Don't go crazy on it. You only put a couple of drops in, 2 or 3, that's it. If you go a bunch more than that, then you're going to start changing the pH of the initial solution. And then if we, up here, we put in our base solution. We do know the concentration of that, and we want to make a very careful reading on our burette tube for the amount that we start with and the amount that we finish with. Now, what we do is we drip it in until we get the color change, and it's going to be right here. So it says if we put 25 milliliters of some unknown concentration of HCl in the flask down here, and it takes 18.8 milliliters of 0.10 molar NaOH to neutralize it. So 18.8 milliliters of this, what is the pH of the initial HCl solution? So what is the concentration of H plus ions and therefore the pH right here in this solution? All right, let me show you how to solve that. This is a very typical acid-base problem. All right, first we write out a reaction equation. So hydrochloric acid and sodium hydroxide react to yield sodium chloride, the salt, and then water. So that just neutralizes it. But the important thing to notice here is this is a one-to-one reaction. One HCl reacts with one NaOH, or 1 mole of HCl reacts with 1 mole of NaOH. So it's just 1-to-1. Now, if this was a 1-to-2, we might have to change our equation here, maybe double this side of the equation over here. But this is just 1-to-1, so no problem. So we have an equation. It's the molarity of the acid times the volume of the acid. And notice the molarity times volume, that'll give us a number of moles. And then in this case, the molarity of the base times the volume of the base, and that is moles. So essentially the moles of the acid are going to equal the moles of the base. So it's a 1-to-1 reaction. All we have to do is plug in our numbers here. So we don't know the concentration of the acid, but the volume of the acid we do know. Okay, and our volume of the acid here was 0.025 liters. So I took my 25 milliliters and I converted it into liters. And that is then my moles of my base, or molarity of my base, is 0.10. And notice I took my 18.8 milliliters and converted it to liters there as well. Now, I divide both sides by the 0.025 to get that molarity of the acid by itself. So we divide those. And that gives us the molarity of the acid as 0.0752 molar. But the question, that's its concentration, but the question was, what is the pH of the initial solution? Well, since it's a strong acid and it dissociates completely, all we have to do is put that in the regular pH equation. So we'll take our 0.0752 molar and put it right here. And then when we do our math on that, we get a pH of 1.12. And so then that number right there is our final answer. So that's how we solve the strong acid, strong base neutralization and do a titration. All right, I hope that helps. Thanks. Bye.